Hello everyone, welcome to Grade Up. My name is Ayush Goel. In these lectures, we are studying data structure, right? In our recent lectures, we completed arrays and linked list, right? I hope you are clear with those topics because those are the base to study more on data structures, right? These are the basic data structures, array and linked list that will be used everywhere in this subject. Okay, so I hope you are clear with those things and you have attempted or practiced much questions on arrays and linked list, right? Now we are moving to next data structure, that is stack. Okay, stack is very important, guys, from programming point of view also, from exam point of view also. Okay, stack is very important. So now we are going to start stack. In this video, we'll see what are the basics of stack, what do you mean by stack, what are the operations on stack, and then we will move on to the applications of stack, right? So shall we start? Okay. See here. First of all, what is stack? Stack is an ordered list, right? Stack is an ordered list in which all insertions and deletions are made at one end called top, right? There is a formal bookish definition, but let us understand what it's trying to say. Let us understand. It is saying stack is an ordered list. Okay, stack is nothing but an ordered list in which all insertion and deletion are made from a single end. See, for an example, see here. Suppose this is your stack. This is your stack. That is the basic methodology to draw a stack, right? I'll tell you why. See here. Suppose you want to insert the elements 10, 20, 30 and 40 inside the stack. You want to insert these elements into stack. So what do you do? See here. First you insert 10. Okay, done. Then you insert 20. Done. Then you insert 30. Okay. And then you insert 40. So these are the elements now inserted in stack. Okay. Now you perform 4 delete operations. Now you want to perform 4 delete operations. How do you perform? You will first delete 40, then delete 30, then delete 20, and then delete 10. Right? I'll take a basic example to understand the meaning of stack. I'll take a basic example. Suppose you have 4 books. See, book 1, book 2, book 3. Suppose you take 3 books. I don't have much space to write 4, right? Suppose you have 3 books. Okay, and you make a pile of books. You make a pile. Pile means one over the other. You make a pile of books, right? Say how? Suppose you first put B1, then you put B2, and then you put B3 on the top. You put B3 on the top, right? So you made a pile of books, B1, B2 and B3. And now you want to take the book 1 outside. You want to take the book 1. How will you take? Can you directly snatch it? No. All the books above it will fall down. So you will first take off the book 3. Then you will take off book 2. And then you will get book 1. Right? That is how your stack works. That is same the stack works. Right? Stack follows LIFO order. LIFO list. LIFO means last in, first out. Last in, first out. What does it mean? Last input. At last, what did you insert it in stack? At very last place, what did you inserted? 40 you inserted. And what will be deleted first? What will be the output first? 40. Got it? The thing which is kept in last will be the first thing which will come out. Okay, that's why they are called as LIFO list. That is last in, first out list. I hope now you are clear with the basic topics, right? What is stack? Stack is an ordered list in which all insertions and deletions are made from one end called top. Now what is top? See here, top. This is your stack. Okay, right now top is -1. Okay, initially top is -1. Top means, what does top denotes? Top denotes the item, or it points to the item in the stack, right? Right now stack is empty, so top is -1. Now you inserted one item, suppose 10. Now top becomes 0. That means your element is at index 0. Now you inserted one more element, 20. Top becomes 1. So top is pointing right now here. So all insertions are made from top. Now you want to delete. Which element you will delete? According to the stack LIFO order, 20. So which element you are deleting? Basically top element, right? So all insertions and deletions are made on top. Got it? Any doubt? Right? These 2 points are over. Now operations on stack. There are 2 major operations. There are more operations possible, but there are 2 major operations on stack. What are the 2 major operations? Push and pop. Basically, nothing is there. Push means insert. Push means inserting the element. Pop means deleting the element. Got it? Simple. You just name them. Insert and delete. You name them as push and pop. Got it? Any doubt in the basic? Right? It is very important. Now, next thing. Implementation of stack. Right? Stack is a criteria, right? Stack is a criteria to maintain this order, LIFO order, last in first out order. I want to implement. But in your system, there are 2 main data structures, arrays and linked list. In your system, there are 2 main data structures, arrays and linked list. So everything will be implemented using these 2 structures only, right? So we'll see also stack can be implemented using these 2 data structures, arrays and linked list. So we'll see one by one how do we implement stack using array and using linked list. Got it? Let us start. See here. First thing I'll take. First thing, implementation of stack using array. First of all, I'll try to implement the stack using array. Right? So see here. Let S be an array. I have declared an array S with n slots. Right? I have an array S with n slots. Say for an example. This is your array S with n. Take n to be 10 for better understanding. For better understanding, take n equals to 10. So it will have 10 slots, right? Draw it. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is your array which has 10 slots, right? Now I want to implement stack. Guys, please remember in case of stack, you have to implement LIFO order. What is meant by LIFO order? Last in, first out. The last input must be the first output. That you have to do, nothing else, right? So see here. I have 2 codes, push and pop. Okay, as I said, that are the 2 basic and main operations on stack. So that I have to implement, right? How should I implement now? Take the same example again. Take the same example. Take 4 elements. 10, 20, 30 and 40, right? First insert into stack, then delete from stack. And delete should be done such that the last input is first output. Got it? So see here. See here. First of all, you take a variable. As we have discussed, you take a variable top. So mark the indexes of array 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You take a variable top which is equals to -1. Right? Initially, when there is no element, you say your stack is empty. See here, your stack is empty or not? So top is -1. Now come on to your main thing. Void push. Char x, right? You want to push the character x. You want to push character x. I have taken integers in this code. Characters are taken. No problem at all. Okay. If you still think something, you can take A, B, C, D also. If you still have doubt, you can take A, B, C, D. As written here, character. So you take A, B, C, D. Right? So see here. If top plus 1 equals to n, basically is the condition for stack full. If your stack is full, will you be able to insert more elements? No. So that is the condition for your stack is full. But right now my stack is empty. I can insert. So I'll come to else part. Now what I'll do in insert, first of all, I'll increment the top variable. I'll increment -1 to 0. Now it is S0 equals to x, right? My character will be inserted in S0. So A will come here. Okay, A is inserted. Up till here, any doubt? Now, do the same thing for BCD, right? It will come to else part, increment the top and will inserted. Increment the top, will get inserted. Increment the top and will get inserted. Okay, I have inserted all these 4 elements, A, B, C and D. Now guys, please tell me, now I am going to pop. Which character must be popped first? Please tell me, please tell me. See, I can draw it here also. As in previous diagram, A, B, C, D. Which element must be popped first time? Which element? The topmost element. D must be popped, right? So after executing this code, which element must be popped? D. D should come out. So see here how, right? We are taking a variable y in which the deleted element will be stored. See, if top is equal to -1, if top equals to -1, that means your stack is empty. That means your stack is empty, right? If you don't have any element in stack, what will you pop, right? So this is for stack empty. But now our stack is some elements. Our stack has 4 elements, right? See here. Y equals to S top. I am writing it here. Y equals to S top. What is the value of top here? 3. Okay. S3 is what? D. Yes. I got the value D in Y. Okay. Now top minus minus. Decrement the value of top. This 3 again becomes 2. Now your top is at here. And then return Y. Yes. Return D. Got it? Yes. After popping, I got the value as D. So is it correct implementation or not? Is it correct implementation? Why? Because it is following the LIFO order. Last in and first out. Got it? Any doubt now? Right? Now we move on to the next implementation, that is using linked list. We now know using array how to do. Now we are moving to using linked list. Right? You all know the meaning of linked list. Linked list is a dynamic data structure in which a group of nodes are connected through pointers, right? All this you know. If you have some doubt in this linked list, you can view those videos again, those 2 parts on linked list, right? Now please concentrate here. Same thing you have to do. You have to implement the LIFO order, last in first out order. You have to implement this order. Now how to do it? See, first you want to insert the elements 10, 20, 30, 40. Same thing I am doing, same thing. How you do? First you build the linked list. How you build? See, first you inserted 10. You inserted 10. Now you want to insert 20. Insert 20 at beginning. If you do like this, say 20 and 10. Okay. This also done. Now you insert 30. Insert again at beginning. I'll tell you what is the advantage. I'll tell you. First, just see here. Finally insert 40. Where? Again at beginning. Okay, this is your final linked list. This is your final linked list, right? Now you inserted these 4 elements. Now you start deleting. Or now I can use the word push and pop. You know the meaning. I have pushed these 4 elements. Now I want to pop. Which element will be popped first? See here. This was your stack. 10, 20, 30, 40. Which element will be popped first? That will be last in first out order. Which element? 40. So now this is your linked list pointed by S. Which element you delete? The beginning element. And you know, I have told you how to insert at beginning, how to delete from beginning. You know these 2 things very well. Got it? So now I'll delete 40 and my stack will be implemented. Okay, see here. Push, insert at start of linked list. Insert at start of linked list. Pop, delete from start of linked list. Right? Do the same things. Insert also at start place, delete also at start place. And you know the time complexity also. To insert at the starting place, just 2-3 lines of code is required. So order of 1. Same for deleting, again 2-3 lines code required, so order of 1. Got it? That's why I inserted at starting place, due to these time complexities. Right? Any problem now? Okay. Now you got how to implement linked list using arrays and using linked list. Clear? Now what are the applications of stack? Basically guys, there are 3 main applications. There are more applications, but there are 3 major applications which are very much required from your exam point of view. They are recursion, infix, postfix and prefix notations, and tower of Hanoi. Okay, these 3 are very important from your gate point of view also and your PSU exams also. Okay, so we are going to concentrate on these 3 things. First, see, recursion. Now guys, you know what is the meaning of recursion. I don't have to explain again and again. Recursion is a program calling itself to solve some particular problem. We have talked recursion in algorithm also. We have talked recursion in programming also. We are talking recursion in stack now also. So you know the basic meaning. Now I am telling the other things which are pending in recursion. Okay, you know, to implement recursion, what is required? Stack is required, right? You know this thing. To implement recursion, stack is required, right? So what are there are four types of recursion. There are four types of recursion: tail recursion, non-tail recursion, indirect recursion, and nested recursion. These are very small topics. Study it and finish it. Okay? Tail recursion, non-tail recursion, indirect and nested. Okay? I'm not going through the basics of recursion. You know all these things. Now I'll not again explain that factorial example how to solve using recursion. Okay? If you have any doubt, see those videos again regarding recursion. See here. Now there are four main topics: tail recursion, non-tail, indirect and nested. Okay. Start with tail recursion first. As in the word tail recursion means there is only one recursive call which is at end of program, right? There is only one recursive call, only one, and where it is present at the end of program. See here, I have taken a program to print the numbers in an array. I have taken a program to print the numbers in an array. Okay, so see here, void print. If n is 0, do nothing. If there is no element in array, don't print. Then print that element, and then again I have called the print function. So there is only one recursive call and it is also at the end. That is known as tail recursion. Very simple guys, nothing is there. I think you got it. Okay. Next thing, non-tail. Now you know the meaning of non-tail also. If you know the meaning of tail recursion, you can know the meaning of non-tail yourself. What is tail? Only one recursive call at the end of program. But will be non-tail, which is not at the end of program. In non-tail, there are statements after the recursive call also. After recursive call, the program doesn't end. There are some statements also. See here, non-tail recursion, NTR. I have taken a function NTR, non-tail recursion. If n is less than 1, or you can say n is 0, do nothing. Else, see, a recursive call is there. This is a recursive call. This is a recursive call. Now, after recursive call, I have some statements. See, after recursive call, I have some statements available. So it is what? Non-tail recursion. Got it? Any doubt now? Okay. So guys, we have studied two recursions up till now: tail recursion and non-tail. In tail, the recursive function is at end. In non-tail, there are some statements below recursive function also. Okay. So now there is some comparison between these two. See, for given tail recursive program, we can easily write non-recursive program. It is very important thing. It comes very often in GATE exam in true-false statement. For given tail recursive program, we can easily write equivalent. See, in our tail recursive, I take the example of printing. Printing can also be done using a for loop, as we always do. Printing can be done using a for loop, simple for loop, no recursion at all. Okay, so tail recursive program can be easily implemented without recursion, very easily implemented using for loop, while loop, whatever. Okay, but non-tail recursive program, which are non-tail recursive, they cannot be easily implemented. If we implement, then we use stack explicitly. Then we have to use stack explicitly. See here, for given non-tail recursive program, if we write equivalent non-recursive program, right? If we try to write, then user have to take stack and should perform push and pop explicitly, right? In our previous, see, in this program, if I try to write this program non-recursively, I can write, but there I have to take a stack and push and pop operations must be done explicitly. Got it? So that is a comparison between tail and non-tail recursion. Clear? Okay. So that's about stack, the basic operations on stack like push and pop, and two types of recursion, right? In this video guys, we started with the basic operations on stack like push and pop, and then we implemented stack using linked list and array, right? We completed these topics. Now we move on to the application. There are some applications. We started recursion. In recursion, we completed tail and non-tail. Now, in our next video, we'll see the remaining two, that is nested and indirect. Okay, we'll see those type of recursions, and we'll see also tower of Hanoi in those video. Okay, so now practice the questions that are available on Stack. Okay, and stay updated. We'll continue the rest of part in the next video. Thank you so much.